Good morning, everyone. So last time we met, we talked about defining our own functions and walked through writing a function together that reads in FASTA file data. So briefly, last time I had mentioned when we were writing that function that we were reading in the file directly in the script. And I said there's a better way to do that. And typically, once you write a good script, you don't want to touch the script again. So today we're going to learn about how that is the case. So we're going to be talking about Argparse. And I want to quickly notice what do like ls, grep, Python, what do all these things have in common? So if I say PFG and I say ls, session 12, I can do ls here. This takes an argument. Similar to like when you remove something, you specify what you want to remove. So the way that those types of arguments are coded at the command line is using a package called argparse. And fortunately for us, because it is so widely used, it's actually part of the native Python packages. So you don't even need to install it. It should come with the install that you already have. And I want to show this script that kind of goes through what it looks like. So this is an actual script that I use if I'm doing some sort of work where I need to download a genome. Typically what I'll do is import my packages at the top, and then I have this little section called setup argparse. And by the end of this session, you should be able to understand more about what's going on here. But the idea is that you define your arguments. So you basically set it up, you initialize it, you add any arguments that you want, and then you finalize it, and then you get to use your command line variables. So here we have an argument called genome, where I say you can choose from any of these genomes. And then there's a thing called outdir, which is the output directory. So this is where you want the genome file to go save to. So then I have in the actual function section, and this is a little complicated, so don't worry if you don't fully understand it. I just want to demonstrate this is what I actually use things like this for. But we see that I have a bunch of different options for the genome, as well as the link to the FASTA file of the genome in the UCSG genome browser. So I create a dictionary where I associate the name of the genome and the link, and then I start processing the genome depending on whatever genome it is, and then organize it and process it accordingly. And that's it. And then when you run the function, it's download the genome. And here, because we specified genome in argparse, this dash dash genome, in order to use that variable, we just say arg.genome. And that will read in the argument that you gave at the command line. So here we're actually going to start setting up argparse in a script of our own. So let me get that up and running. So you should be able to navigate to your Python focus group and go to session 12. And we are going to create a file. I don't know if argparse.py is going to mess up the environment or like the native argparse. So maybe don't name it argparse.py. So I'm going to name it smiley argparse.py, and you'll see why once we get that started. So I'm going to go ahead and open that with my text editor now. Okay. So as per usual, we'll have our little interpreter directive, but you know at this point, it's not strictly necessary. It's just helpful and kind of organized. What we're going to do now is import argparse. And if you want to test just to make sure your environment has it, it should, but you can just run Python 3 smiley argparse. If it doesn't throw anything up, it imported perfectly fine. So now I'm going to start introducing some ways that I like to organize and format my code for readability purposes. I always like breaking up my code into sections, like major sections of what I'm doing. So usually I'll say something like import modules, and then I'll create what looks like this giant banner type thing at the top so that when I'm scrolling through my script, I can easily see the different components. And after this, I'll do setup argparse. So I'll do two of those and say setup argparse, and then just fill in the blanks. So this separates my code into like nice kind of logical blocks. And remember that anything starting with the pound symbol just kind of gets ignored by Python. So this is nice for formatting and readability, but doesn't actually impact the code being run. So here, there's going to be three major steps, which is initialize argparse, set up arguments, and finalize argparse. One thing I would quickly like to note, I just want you to focus on understanding how these things work rather than the exact syntax. And the reason I say that is because I do not ever write this from scratch. I almost exclusively resort literally to this exact template and just copy and paste it and then adapt it every time I need to use argparse. So you don't need to focus on like, oh, this is like some weird caret symbol or something like that. Just understanding the general outline of what we're looking at and how to use it. So when we go to initialize argparse, again, I just kind of copy and paste my template. We have different pieces. So you have to set parser equal to argparse.argument parser. So this is just something native to the argparse program that is telling Python to initialize the process that parses your command line arguments. And usually there's a description here, and we want to put the description as something actually relevant to the script. So like when we were looking up here, the description was download and process a genome to create a genome.fa file. So you want it to be informative so that when you're looking at your program or if you print help, then you can actually see the outputs or description of the program. So this is just helpful for, your own sanity. So we're going to have some fun and do something first non-biological and then revisit the function from last week. But here we're going to say print any number of smiley emoticons on the same or a different line. So we're going to print some smiley faces. That's what we're up to today. And right now we're going to leave the setup arguments part blank because we need to think about the arguments we want. But the next thing we can do is do the finalization of argparse. So in order to do that, I usually just copy this line where it says arg equals parser.parse args. So what this is doing is essentially parsing your arguments and assigning the arguments at your command line to arg, which is why in this script, instead of saying genome, we say arg.genome because it's talking about the argument given for the genome variable, the argument given for the output directory. So it's reading this in directly from the command line. So now that we have done this, the initialization and finalization, these are super easy compared to the required arguments because now we actually have to put our brains to use and think, what do we want to use? So since we're going to be printing some smiley faces, I think something we can start with is the number of smiley faces we want to print. So here we're going to add a required argument, and this is all coming from the markdown. But I'm going to separate or open this so we can look at it more thoroughly. So here I'm telling the parser to add an argument called num. So we're going to be able to use this as the arg.num. And we get to specify if it's required as true or not. And this is relevant because let's say when you're running a genome alignment or a read alignment for RNA-seq, there's a lot of default arguments, but you don't have to have a default. So this is similar to when we talked about functions where you can specify something as a default. So if it's not required, you can specify a default and put the required as false. And then if the person puts the thing at the command line, it'll read and use it. If not, it defaults to another behavior. If the requirement is true, let's say you're doing that alignment, it needs a FASTA or a FASTQ file in order to conduct alignment. You can't just carry out alignment without giving it any reads to align. So that's a required argument, for instance. So you can say required true. You specify the data type. So since we're printing the number of smiley faces, we'll just put int. So you can put string, you can put Boolean, but here, since we're working with numbers, we just put int. So this is still the same data types that we've already talked about. And then the var, I think that just provides a name for the argument in the help message. So it acts as a placeholder to indicate the type of values expected. So if you put help, it'll print out something that looks like dash dash num int. So this is what prints out for the help argument. It's like, okay, so if you're asking for help about what the program does, it shows you that it's expecting an integer. So this is just metadata stuff. And then you put the help message. So this is required integer argument to choose number of smiley emoticons to print. So the first thing I want to do before we even run anything is just demonstrate if we do this and then dash dash help, it prints out all of our help stuff already formatted. So it says the usage is smiley argparse.py. By just having argparse being used, you can enable this help message with dash h or dash dash help. And it says show this message and exit. This is what shows the usage. So it says smiley argparse.py dash h and then dash dash num. And this is an integer. So it's saying it needs you to put a required argument here that's an integer. It'll print out the description of the program. So it'll say print any number of smiley emoticons on the same or a different line. And then it'll give you the actual options. So this is where it'll show options that are required or not required. So it'll show all options available to you. So this is where it shows the dash dash num int and says required integer argument to choose number of smiley emoticons to print. So essentially everything that we have done so far is just setting up some stuff to be able to read in our arguments from the command line and make our script usable outside of just editing the script ourselves. So now that we've done that, we're going to go ahead and actually do some stuff. So here we can say, I'm going to move this back out of the way. At this point, it functions mostly like a normal script. The only difference is if you want an argument, instead of putting the argument in the, or instead of putting your variable in the script, you're just going to use the variable at the command line. So here we'll say main functionality. This is what I put sometimes if there's nothing in particular that I'm doing other than like one thing. So here we'll say a equals and then set it equal to smiley face. And then we'll say b equals, and then remember that we want to be able to print any number of smiley faces. So we can just multiply this by the number of smiley faces that we want to print. So we can say b equals a times, and then in order to access this, we just say arg.num, and then we print b. So now when we are using our Python script, the smiley argparse, we can say dash dash num, and we can do an example with 3. So what it's essentially done is say it's going to read a is equal to the smiley face, a times 3, so then it prints 3 smiley faces. We can now change this to like 100 if we want, and now we've printed 100 smiley faces. So this is a really kind of silly example, but what I'm trying to show here is that if you write a good script, specifically for Python scripts that carry out major functionalities, the idea is that you're not interacting with the script itself. Once the script is written and it has the functionality you need, the goal is that anything that you would have to change that's a variable, an input, an output should be done at the command line. This is generally really good practice, and because of that, argparse is probably like one of my most used imports. Like I can probably open any script and it probably has argparse at the top of it. And we'll do that to check my sanity. Here. So here's a Python file. Wow, of course this one doesn't use that. Let me go to like I know I've been doing some stuff with PPP2R5D lately. Yeah, so here's argparse. So then I have the usage at the top. I show my counts file, my metadata file, and the output that I want. And then I have my setup argparse section where it has my required arguments. They're all true. It has the data type, so it's a string for all of this, and then path to counts file, path to metadata file, output file formatted as a text file. So yeah, this is one of the most used things that I have, and I think I just really want to convince you that it's worth using and that you should use it in all your scripts. So yeah, as another demonstration, we can just change the number to whatever we want. You can say 1,000. That's what 1,000 smiley faces looks like. So this is great. We have our required arguments, but what about the optional arguments? I had mentioned that sometimes we don't really need an argument for everything. Right now, as it is, if we run this without the dash dash num, it's going to crash and say it requires some sort of number. So what if we actually change this to false and give it a default? So now we're going to change this from a required argument to an optional argument. And instead of it being required, we're going to say false and say, here we'll add a default. So we'll say default equals 5. So now that we have set the default, if we go back and run this, the same thing that gave us an error message before now prints 5 smiley faces. And that is because we have taken this. Here it says the following arguments are required because it used to be true. But now we have set that to false and given it a default because we still need some value to populate later in the script, which is where the default comes in handy. So every time I run this, I get 5 smiley faces. But what if I want more? So this is where the optional part comes in. If I want more, I can say dash dash num and say 20. And it now overwrites the functionality of the default because I have given it an explicit instruction to do something else. So that's what the difference is between required and optional arguments. You can put default arguments. The other thing I want to note is there's this really weird thing called an Argparse switch, and it took me a little while to get used to this. So I'm going to try to demonstrate what it is. So we'll say switch, and this is a little bit different from our required or optional arguments because there is no required portion. All it means is that if you put this at the command line in any capacity, it stores true. So this is where our Booleans are going to start coming into play. So an example of this is if you're running sequence alignment. You have your RNA-seq reads and you're trying to run sequence alignment, and you have your genome. If you have single-end data, you don't have to do anything. But if you have paired-end data, you have to add a, let's say, a dash dash paired or something like that. So what this essentially does is if you add the flag, you don't give it an actual argument. You just add the flag and it will carry out a slightly different functionality. So by storing true, we can use this as a Boolean. So here our help message is going to say, if used, the smiley emoticon are printed on the same line instead of different lines. So now, since this is a store true versus false, we need to adapt this to be a conditional. So now let's edit our functionality a little to reflect that. So our options are either same line or different line. So if we want it on the same line, same stores true. So we can say if arg.same, which essentially means if you are using dash dash same on the command line, this evaluates to true. So it's basically saying if the user puts same at the command line, then carry out this code. So this is what we've been doing. So we're just going to copy that. And now we have our different line. So since we have our if statement, we can say else. And the big difference here is if we wanted on a different line, we can put a line break character. So that dash n, and that will cause a line break every time it runs. So the functionality now says if we use same, it'll print on the same line, and if we don't use same, it'll print on a different line. So let's give that a shot. So we'll say dash dash same, And now we see the interaction of multiple different arguments. Since we didn't put the dash dash number, it's defaulting to 5 smiley faces, but it's printing on the same line. If we omit this, it prints 5 smiley faces, but it's printing on different lines now because this is evaluating. So if arg.same is false because true is not being stored because we didn't use the same flag. So again, this is saying like since we didn't use this, it's going to evaluate to else and print it on a different line. But since we have other variables here or other arguments, we can run them in combinations. So we can say, I want the same line, but I want there to be 100 of them or 1,000. Let's do 100. Or I can say, I don't want them on the same line, but I do want 100. So see, just like that, by adding these sections up here, just this Argparse section, we've essentially been able to make our program flexible enough that we can output all sorts of different combinations of things without actually having to change the script. This is ideal. You don't want to change your script after it's written. And this is more important for user-facing things that are written. So if I'm writing, say, let's say Nick is like, hey, Vicky, I want you to help me find some guide RNAs in this FASTA file. Then it would make sense that if I wrote a file, I would have it input the sequences and input the FASTA file and then output something. So I could set it up so that once I send them the script, they're able to look at the script and just put the variables they need and run it on their own without having to change anything in the script. So anytime you're doing something user-facing or sharing your work or even just trying to make your work reproducible, use Argparse. So yeah, that is kind of the functionality. Like it's not super complicated, but I do want to revisit that genome script and then we'll take a look at our old script, the FASTA file reading script. So now that you understand Argparse, here we can see we have initialized Argparse. We add an argument called genome, and the options are DM6, HG19, HG38, MM10, and so on. And then we have an output directory that says where to store our output. So when we run download genome, it says arg.genome. So this is running the function, but our function says genome. So it says the link is the genome link genome. So if I put HG19 as my genome, it's going to save the link associated with HG19. And then we see that this ends with chrome fa.tar.gz. So that follows the if link.ends with chrome.fa.tar.gz. It will do all this stuff accordingly, and it will save and organize as needed. So that's kind of the flexibility. With just one script, I can download any of these different genomes, put them anywhere that I want output, and process them with just this one script. And that's all because of Argparse. So now I do want to revisit our FASTA function. I recommend if you do not have this open yet that you open it or you open the file from last week because we're going to make some edits. So last session we made this function. I am going to initialize a new file for this really quick. So I'll say touch FASTA function.py. And now we can open FASTA function.py. So I'm going to show you how I like to pretty up some scripts. So we made this function. I would just copy and paste this. We've already gone through what each of these things does. It's copy and pasted from the last section. And then we have our sequences.fasta file. So copy this and create another sequences. So here we'll say sequences.fasta. I used nano because it was just a very quick thing to add. So that looks fine. So now that I have our files set up, remember that when we wanted to run this, we had to run at the end of this for name sequence in read FASTA sequences.fasta print name sequence. But that means every single time. So going back to that example of if I wanted to share this code, let's say I sent it to Cassiana, she would have to open this file, go and edit this line, which requires her to, in some capacity, read through the code, understand what it does, and edit the things that are appropriate to edit. Or we can use Argparse. So we're going to do that. So we're going to take this function and we're going to pretty it up to turn it into a nice, beautiful, usable script. So I'm going to put my interpreter directive on top. I like to always put usage instructions. So I think that example of the script I opened from some of the work I was doing recently, I put my usage instructions at the top so that I can see what I need to run. And this kind of helps me format my code too, because I'm like, how do I want this to run? How do I want this to work? So we know that we're going to run Python 3 fasta function.py and then dash dash fasta and some sort of input. Because instead of reading in the FASTA file directly, we're going to read in the FASTA file from the command line from now on. So here we can pretty up our stuff. So we'll say import modules. And we're gonna give this some space really quick. Give us some time to work. So we already have gzip imported from our previous functionality. We also know that we want argparse. So we're going to say import argparse. Now this is where I want to demonstrate how I use the Argparse template. So at the bottom of this, I have an Argparse template. And again, I almost always copy and paste this. Since we already have these portions done, I'm just going to copy this setup Argparse piece. And we're going to go through and just change what we need. So when it says initialize Argparse, we have description of program. So we're going to adapt that so that we can say something like associate FASTA sequence headers with their sequences. There really isn't an optional argument because we need a FASTA file in order to run this, so we can get rid of our optional argument. There's not really a switch we need because we need the FASTA file and it's a pretty straightforward program, so we can just delete that. So there's only one argument. So required argument, we want it to be FASTA. So I'm going to change this from required argument to FASTA. It is going to be required. It is going to be a string because it's going to be a file path. Here that's consistent with the string, and then description of the argument. So we'll say FASTA file input. So now if we run this with help, what did I do? Oh, let me comment all this stuff out. There we go. It was reading in the stuff that I forgot about at the bottom of the script. So yeah, it says usage fasta function.py, help, and then dash dash fasta with string. And then it says the options are fasta with the fasta file input. So now we have our function already, so we can say define function. And we've already done the work for that. So if I'm writing a script from scratch, usually it will also, in addition to doing what we're doing today, I will go through the process we went through last session where we're sitting there kind of troubleshooting and doing what we need. But we already have our function, so this is fine. And we're not going to have to run this function because we are going to run it with the command line. So instead of define function where we have the sequences.fasta, now we can just have a section execute function where instead of saying read fasta sequences.fasta, now we can replace this with our argument. So since it's our argument read in from argparse, it starts with arg dot and then whatever the argument is. So this is FASTA, so we say arg.fasta. So now we can try to run that. So we can say Python 3 fasta function dot py dash dash fasta, and we'll give it sequences dot fasta. Okay, this is an artifact, and I will explain what is happening here. It says tab error, inconsistent use of tabs and spaces. Some programs, see when I highlight this piece, it highlights the whole thing. That's because those are tabs, whereas here I have it as individual spaces. Python doesn't care if you use one or the other, it just prefers you pick one. So my text editor just has an option because of how common this is to do blank operations. And then I say space to or tab to space. So it just converts every single one of the tabs I have into a space instead. So now it shows the orange parts are what's been edited. So now see when I do this, I can select stuff in the middle because these are just spaces now. This is not a crazy error to run into. It's nothing wrong with your code. It's just the formatting. This happens occasionally if I'm copy and pasting stuff from different scripts, or in this case, like the template that we had online. So now that should be fixed. And there we go. So we say Python 3 fasta function.py fasta sequences.fasta, and it carries out our functionality. Now I'm pretty sure somewhere else I have another FASTA file I can probably read in. Or not. Maybe I don't. Let me see. If not, that's okay. But I'll try to see if we do. Aha! Okay. So to demonstrate the flexibility, we wrote this with the intention of printing sequences.fasta, but now without even having to change the script, I can say, instead of sequences.fasta, I'm going to go up a directory, 2 directories, and that takes me to my GitHub stuff. And I'm going to do 2026 CDKL5 reactivation, single cell references, and then I have a file called custom.fasta, I think. Yeah, custom.fasta. So custom.fa, and these are the sequences. So these are sequences Camille sent me of the SCP construct, the mini VPR, the poly A, the HTET1CD. So this is another FASTA file I have saved, but this is just to show you, just like that, we were able to go from reading in the one we had locally to just giving it a different file path, and it was able to carry out the functionality we wanted. So that's about it for this session. I didn't want to overcomplicate or overcrowd it with too many new concepts, but the big takeaway is that if there's anything being read into the script in any capacity, or anything that's a variable that you want your user to think about, like the input file, the output directory, anything of the sort, you should probably use Argparse. And again, like you don't need to understand every single specific of the formatting for this, just that there's the initialization, you have required arguments, you have optional arguments, you have switches. They all behave slightly differently, as demonstrated with the smiley argparse thing we did. And then you finalize it, and then you get to use your variables. So yeah, that's all we have for today. Are there any questions?
How did you when you had the issue with the tabs and spaces, I think that you were having that issue too. Where was that happening in the code?
Let me show you. So it was happening because, let me see, there we go. I think, so I just clicked Control Z to undo it. Yeah, so we have, it says line 43, inconsistent use of tabs and spaces and indentation. So it's saying starting right here, I go from using individual spaces to using an entire tab character. So if I click my arrows, it's treating this as one character, whereas here it's treating it as multiple characters. So in order to fix that, are you using Notepad++? I think you're muted.
Sorry, yes, I am.
Oh, okay. So yeah, so go to the edit section. So there's a top part that says edit, and then scroll down to where it says blank operations. And then there's the bottom three options, tab to space, space to tab leading. It doesn't matter if you do tab to space or space to tab. I just prefer personally tab to space because then it doesn't mess up any of my spacing that I currently have in my script. So I just do tab to space and then it will fix it. So it'll say, oh, well, now this portion here that was a tab, before I couldn't do this. Now it replaced that tab with spaces. So that's all. It took me a while to figure that one out because I thought that I used to have to go through and do it manually until I was like, ah, there's a text editor function for that. So I wasted many an hours of my life trying to do that by hand. So there's better ways to do that.
Good to know. Good to know. Thank you.
Yes. Are there any more questions? All right. I guess I will see you guys at lab meeting in 20 minutes. Thank you for coming.